Hi, welcome back everyone to Organic Chemistry with Clued. I hope your semester's all going well, and today we are going to be talking about how to name alkanes, alkenes, and alkynes and some simple tricks to remember the prefixes. This table is explaining the prefixes of the parent carbon chain. In application for Organic 1, you really only need to memorize the prefixes for 1 through 10, which is meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. Check with your professor because sometimes they do include an undec or a dodec, but typically you're just going to be seeing those first 10 prefixes. When naming alkanes, alkenes, and alkynes, the suffix ending of the parent carbon chain name is going to be a little bit different. So for alkanes, it's going to end with ane or ane. So methane, ethane, propane, etc. For alkenes, it's going to end in ene, like heptene, octene. And for alkynes, it's going to end in ine, nonine, decyne. And this is easy to remember because you're just taking the last few letters or the suffix of that actual name of the alkane, alkene, or alkyne. A mnemonic device that I found pretty cool to help remember the first 10 prefixes in the IUPAC naming has to do with elephants painting, because who doesn't like that? Meth starts with an M. That first one's going to be many. Then elephants, paint, beautiful, portraits, hoping, humans, offer, nice, donations. So take the first letter of the way you're remembering it and the first letter of the actual prefix, and that might help you remember what it is. This slide right here is pretty much the gist of naming alkanes, alkenes, and alkynes. Got inspiration for this from one of my professor's lecture videos. If you haven't checked out her YouTube channel yet, I highly recommend it. It's called LSSU Chem 225. She posts all of her lecture videos online for the public to see, and it is super, super helpful. So to name them, the first step is to identify the parent chain, which is the longest chain, and then for alkanes, it's the longest with the most substituents. For alkenes, it's the longest with the double bond, and alkynes is the longest with the triple bond. Because if you remember, alkanes are all single bonds, alkenes includes at least one double bond, and alkynes include at least one triple bond. Step 2 is just identifying and naming the substituents, which are basically the little things that are hanging off of the parent chain. Step 3 is numbering the parent chain and assigning the locant numbers. This is so you're able to identify the names of the substituents, because you need those locant numbers when naming the compound overall. For alkanes, you just got to make sure that the first substituent has the lowest numbering. If there is a tie, you go to make sure the second substituent has the lowest numbering possible. If there's a tie again, then you can do it through alphabetical order. For alkenes, you just got to make sure the double bond has the lowest numbering possible. It might not necessarily always be at carbon 1, but it has to have the lowest number possible when you're assigning the locants. And then for alkynes, again, just make sure the triple bond has the lowest numbering. Step 4 is listing the substituents in alphabetical order. You place those before the parent name. When you're ordering them in ABC order, ignore the prefixes except when the prefix is iso. In that case, consider the I as the letter when you're ordering them. And then a few notes for some exceptions. If your parent name is in a ring, that typically happens mostly with alkanes, you just add cyclo prefix before the parent name. And then again, like we mentioned before, you add the suffix ane for alkanes, ene for alkenes, and ine for alkynes. For alkenes and alkynes, you have to assign a locant number for where the double or triple bond is. You do not need to do this. It's not necessary if the double or triple bond falls on the first carbon, but you can if you'd like. That number can either be placed just before the parent name with a dash separating it again, or you can actually break it up into having it just before the suffix. So an example of this would be 2 Dekine or Dek 2 Ein. It does get a little more complicated when you're adding multiple double or triple bonds into the parent chains. However, this is just the basics. Okay, and now we are going to go over 3 quick examples. The first one being Alkane, the second Alkene, the third Alkyne. These examples are not narrated, so feel free to hit pause and write down the example and try it on your own before checking the work. Okay, great work everyone. That's going to conclude the video for today. I hope you have a great rest of your day and good luck in the upcoming semester. Thank you.